Hello, I am Dave Ackman of the Gateway Division of the National Model Railroad Association, and I'd like to welcome you to the second section of my seminar on automating computer-aided design for 3D printing of model railroad structures using a technique I call generators. My goal today is to expose you to the concept of a generator, a way to create custom model railroad structures without learning computer-aided design, and show you 15 to 20 samples of how I use them. I do not intend to make you experts of any single generator, but instead convince you to take a look at my website, http://dackm.github.io, to download the library and experiment to see if the technique might be useful to you. For me, it has greatly accelerated my ability to create custom buildings and do so with greater precision and creativity than I ever thought possible. I believe it can do so for you too, and it's free. If you attended the first section of this clinic, either at Gateway 2022 or perhaps in a virtual clinic I taught for your division in the last year, great! But if not, let me bring you up to date. I really like creating structures for model railroads, particularly using my 3D printer. But doing so required learning computer-aided design, which is really hard. And the software requires a certain manual dexterity that folks over 60 may lack. I was born in 1948, which makes me a really old guy. And early in 2022, I got frustrated with all the work I had to do to create distinctive models. To make a structure required so many iterations to satisfy me. Dimensions needed changing. I would get a new idea. I would slip and run a cut, and then it was back to the hobby store for more materials. And I was never really pleased with the variety of styrene pieces available commercially. But I am a retired computer scientist and still know how to write programs for Microsoft Windows-based personal computers. What if I could write a program specific to an individual type of structural component? A program which was basically a form describing a primitive, like a four-walled building or a shake-shingled roof. What if the program would generate a 3D model for me that I could print on my 3D printer, currently a Bamboo P1S I bought for about $600? I can do that, and so I did. I made a bunch of them, and I call them generators. Best of all, they are yours for free. At the end of this presentation, I'll show you how to download the programs. But for now, know that there is a link on my webpage, http://dackm.github.io, which downloads a zip file with all the executable programs. Everything runs under Microsoft Windows. The internals of my programs are my secrets, but you are welcomed and encouraged to use my generators to create your own custom structures free of charge. For starters, here is a generator I introduced in 2022, which creates a basic four-walled building. At the top of the form, there appears a set of radio buttons, where I select the style of the walls on the building I wish to create. If any option is grayed out, like the one for brick walls, it indicates that I intend to add that feature sometime in the future. Below that are input parameters which specify the footprint of the building, most notably its width, length, wall height, and roof pitch. The substrate thickness represents the thickness of the walls. And for a clapboard building, we get to specify the height of each board and the angle of the boards from vertical. All of the defaults are pretty good for starters, but if you modify them and want to save your parameters for a later date, just click on the light blue Save Parameters button to save your desired values in a file for subsequent reloading with the maroon Load Parameters button. You need not look too closely to see that there are no windows or doors just yet, just 4 walls, but the details will come later. Trust me. Different wall types have different options. For example, log cabins have options for log diameter, how much to overlap or plane each log above the one below so that they don't roll off each other, and how much to overlap them in the corners. Boards and battens have options for board width, how wide each batten is to be as a percentage of the board width. If you make the percentage high enough, it will begin to look like the battens are inside the boards. And how much higher each batten is than the board. Note that dimensions are in millimeters, not life-sized units. This means that the generators are scale independent. You decide how big the final object will be and design it to fit your railroad. And here we have samples of a log cabin and a board and batten structure. It's all the same program for a basic building, just different options. But we did skip a step. Clicking on the green Generate button does not create a 3D model file. It creates an SCAD file, which in turn creates the 3D model. But what's an SCAD file? SCAD is a 3D modeling language supported by a free Windows-based program called OpenSCAD, which can be downloaded from http://www.openscad.org. The language allows us to describe 2D or 3D objects we wish to create, including solids and holes. Here we see the specification for cubes and cylinders, along with their positioning. Our generator allows us to create objects we want by filling out a form, kind of like ordering something from Amazon, and the generators translate our specific wants into tailored geometric specifications. When OpenSCAD is started, we click on File, Open File, to import the SCAD file the generator created. We see a rough depiction of the structure primitive we just created. If we like what we see, we hit the F6 key to render the object, which takes anywhere from a few seconds to about a minute, during which time the rough image will disappear. I say a maximum of a minute, but one really big brick wall with over 2,000 bricks took about 5 minutes. When the rendering is complete, we just click on the STL icon to create a stereolithography model file suitable for slicing and printing. Voila! A 3D model of our design, and we did not need to learn computer-aided design. Let's run through the entire process again from end to end. We start a generator, change any parameters we desire, and if we desire, we save the configuration in a file of our choice. Then hit the green Generate button to save the design in a format compatible with OpenSCAD. We then launch OpenSCAD and open the specification file we just created. We can pan, zoom, and rotate in OpenSCAD. If we like what we see, we do a design render, or hit the F6 key, which does the same thing. When the render is completed, we click on the STL icon to create the 3D model. At this point, we can slice and print the object, or import it into a CAD program for additional modification, and then export the modified object for slicing and 3D printing. While this clinic is about what's new, I do want to show slides of what was available last year. You've already seen the basic building generator with its 3 siding types. We also have a roofing generator, which can create board and batten, fish scale, and diamond-shaped shingles. There is a separate generator for shake shingles, but by changing the parameters and turning off the randomization of shingle sizes, this same generator can create standard tab shingles. I also made a generator to create brick walls, which, with the creative use of holes, can be the starting point for all sorts of storefronts and other structures. And by altering the input parameters, this same generator can create concrete blocks or other regular rectangles, even mitering the vertical edges. Another generator creates plank flooring for building interiors and exterior decking. Still another creates concrete foundations. I am particularly proud of my window generator. This generator allows you to create multi-window windows, multiple sashes per window, multiple panes per sash, and to raise the sash as desired. You can control the overall window size to your specifications. I'd like to add pediment features in the future. At the Gateway 2022 NMRA conference, I presented a quickie tutorial on how the free Tinkercad software could be used to punch holes in walls of a basic building to make spaces for windows and doors. And this tutorial is now available independently on my website at http://daacm.github.io. Learning how to punch holes and align objects are two of the 9 major things to learn with any CAD package, so spend 8 minutes with this tutorial and learn the basics of computer-aided design. And with that introduction, you are now up to date with where we start part 2 of my Automating CAD clinic. You are going to see generators I created since 2022, enhancements to the generators I introduced back in the original set, and ways to combine generated objects into more complex structures than I anticipated back in 2022. So what's new since 2022? How about awnings and arched roofing, billboard supports, trestle beds, construction tools, rafters, pillars and purlins, operational garage doors, circus tents, fences, water towers, shutters, louvers, and hip roofs? These generators are probably the reason why you decided to attend this clinic. My very first clinic ever was on creating billboards from styrene, and I developed fixtures from ultra-high molecular weight polyethylene, or UHMW, to make assembly easier. I have a complete woodworking shop in my basement, so creating these fixtures was easy for me, but near impossible for most other folks. So I invented a generator for billboard supports. You just need to specify the dimensions of your artwork, how far above the ground the billboard should be, whether you want a space for a toe gap, and what parts you want to create. The face frame, boardwalk, and leg assemblies are all separately designed components. I also created an assembly fixture to aid in attaching the legs to the face frame. Keeping the legs perpendicular to the face frame is tricky, but my fixture stabilizes everything by inserting the boardwalk extension through a hole in the fixture. Just be careful not to glue the billboard to the assembly fixture. I am currently developing a generator for awnings. Growing up in the 1950s, before air conditioning was common, I remember awnings everywhere on residential windows and commercial storefronts. This is a complex generator, as there are so many awning profiles, and the user interface was tricky. I deviated from prior generator designs and presented images of 4 awning profiles from which the user is allowed to pick the basic design. Of course, there are the basic width, height, and overhang parameters. While awnings are basically triangular, they can be enhanced with extensions on the back or bottom. Gutters were created to resemble seams, and scallops or triangular shapes added as fringes. Your own painting or custom decals will add to the effect. Awnings can be placed back to back to resemble a tent, or placed on a separate leg set for an entranceway to a fancy restaurant. You are on your own to create a red carpet. Hollow awnings may need supports when 3D printing. While only one of the 4 profiles has been created at the time of this writing in late June 2023, I am committed to creating the concave and convex awnings in the near future. The quarter sphere awning is complex and may be dropped in favor of the arched roofing generator. And you are probably wondering what this arched roofing thing is. In recent years, I have been seeing more and more plastic arched temporary structures along the road, providing protection for salt, sand, or gravel piles. I came to realize that these could also be used to cover grain, serve as garages or machine sheds, or who knows what. This roofing style is often found in commercial structures, even today. They provide limited but inexpensive protection, so I decided I need to create them. Initially, they looked to me like bread loaves, and the name kinda stuck in my mind until I learned they were actually called K-span structures. These things are basically ellipses, and you can create tall ones for barns or short ones for old commercial buildings. Circular roofing is achieved when the 2 axes are the same dimension, but remember, the height of an arched roof is a radius and the width is a diameter. I was intrigued with creating curved end caps for the roofing, and I did. But in practice, the end caps are usually flat, like a board and batten. My basic building generator makes it easy to create such a wall, and the mask function allows you to create a mask for a standard flat wall to cut out an exact shape for the arched roofing. Just make the width of your mask match the width of your end cap, turn the mask into a hole, align the objects in Tinkercad, and export the STL file. I like to make the dimensions of the roof a bit larger than the basic building to allow for an overhang. I really hesitated to do a generator for trestles, but in the end I created a simple one with 3 options. The first option creates a trestle bent with solid sills. The second creates one with horizontal planks connecting the pillars, and the last one creates only the solid sills. I created the first 2 as more complete solutions, and the last to allow you to use your own wooden dowel rods for the pillars. When choosing the option with horizontal planks, and when slicing the bents, I suggest using slicer-generated supports. The areas between the pillars can be removed easily with a punch by knocking them out from the top. I print my bents horizontally to reduce stringies. When printing only the solid sills, getting the dimensions for the holes in the sills is problematic because the diameter of any set of dowel rods is inconsistent. The way around this problem is to make the holes a bit undersized and then ream them out with drill bits to fit your dowel rods. I like to use wood-impregnated PLA for trestle bents because the sills and the supports can be stained rather than painted. Pillars in wooden trestles are usually 14 to 20 inches in diameter, larger than I expected, so don't skimp on the sizes. I stopped at the trestle bents and left the cross bracing to you. When it comes my turn to build a trestle bridge, I probably will make an assembly fixture that keeps the bents evenly spaced and vertical. When I get one designed, I'll let you know. I really wanted to do staircases and do them well, but I haven't figured out a good user interface. Like awnings, staircases are a real challenge because there are so many options. Open or closed sides, freestanding or next to a wall or between two walls, straight or curved. What about landings? And then there are handrails, which lead us to fire escapes, a whole additional complexity. Just a lot to consider, and frankly, the complexity is intimidating. The International Residential Code, or IRC, recommends standards for the ratio of the rise versus the run for well-designed staircases. About 7 3/4 inches of rise to every 10 inches of run in real life. And there are also considerations for the overhang or the nose on the step over the riser. And any good generator would have to consider these recommended ratios. Yet I found myself really needing a simple staircase for my Moss Brothers freight house. Initially, I manually wrote a simple OpenSCAD program without a user interface and hard-coded the parameters, and it worked. Nothing spectacular, just a solid structure with handrails. Now at least I had something. Seeing the need for a generator, I wrote a user interface for this simple project, allowing me to alter the basic parameters. I added a small option to change the solid base into a hole to make it look like stringers from the side. The tongue was created to provide a gluing surface for under a deck, but could be eliminated for a simple staircase for something like a front porch or back deck. My original roofing generator has gone through the most extensive evolution. First, I wanted to create rafters. The existing roofing generator allows for the specification of the building length, span, and pitch, so I used these to design a basic truss. The number of trusses can be specified, and the number of stringers connecting each truss as well. The sizes of the truss members is also under your control. If you want vertical corbels to attach to the wall, well, that functionality is available too. One day while picnicking, I observed that a park shelter is really quite similar to a building, just without walls. So I created a pillars option. You can specify the number of pillars you want. You can have more rafters than pillars, but do the math so that there will be the same number of rafters between each pillar. A purlin is just the big beam that goes across the top of the pillars and which supports the rafters. You can create angular supports to connect the pillars to the purlins. I wanted a way to create supports for docks. Loading docks, fishing docks, and maybe even back porches or balconies. Nothing fancy, just sets of legs with diagonal cross bracing between legs and stringers between the leg sets. So I wrote a generator for this task. Things worked out best when I printed leg sets horizontally and then assembled them in a fixture. This generator asks for the size of your 3D printer's build plate, the height and diameter of your pillars, the distance between leg sets, how long the entire string of leg sets will be, and what angle you want the bracing to be between pillars in a leg set. There are additional buttons to generate an assembly fixture. I started out designing the pier set as a single unit with vertical supports, but when I printed the unit, there were so many stringies, wisps of filaments between supports, that I changed my design and placed them flat on the build plate. But doing so made assembly more difficult, so I built a construction tool into the generator to place the supports vertically for alignment and gluing. While the fixture can be used directly, I decided to tape it to a piece of UHMW, ultra-high molecular weight polyethylene, and drill through the support tool to create my fixture. Why? To keep my fat fingers from gluing my supports to the fixture. UHMW is quite slippery and glue rarely sticks to it. Operating garage doors are new for 2024. This generator creates two separate pieces, the door itself and a support with a hole for an axle in which the door rotates to open. There is a floor in which the support rests, and the support may be built in an existing structure. While the door may be a flat windowless piece, options are available for different window configurations. Single and double doors can be created by altering the width. In a celebration event in 2024, I got gigged on a model because I did not have rooftop details. Out of that came a generator for creating water tanks, like were used in New York in the early 1900s to increase water pressure by placing storage tanks on roofs of taller buildings. I expanded on it to also create municipal storage tanks for small villages. As always, the dimensions are under your control. I probably wanted a circus tent since I first got into model railroading. Cloth ones are available but are expensive, and I decided to give 3D printing them a try. This generator creates the end cones and a connecting straight section. The tension parameter controls the slope of the tent from the top of the skirt to the peak. Another option allows for the creation of a painting mask for the triangular sections of the cone. Real circuses often used sawdust to cushion the performance floor, and I eventually want to create a way to fix the tent components together in a solid piece to contain some of the sawdust-like media. I thought shutters and louvers might be more interesting than I have found them to be. While I place windows in holes that I punch out in Tinkercad, I print and paint the shutters separately and insert them into half holes around the windows, aligning the holes with the face of the wall and then moving them back about half the thickness of the wall. I do the same thing with louvers. Depending on your printer and how well it is dialed in, you might have to make the half holes a bit oversized to accommodate for elephant foot, where the first layer of the print oozes out a bit more on the build plate than it should. Or you could sand the edges of the shutters back just a bit or print the shutters undersized. We probably should mention doors. I do not plan on creating a generator for doors. They are just too simple to create in Tinkercad to justify the effort of creating a generator. But if you like, you can visit my website at http://dackm.github.io. Go to the Table of Contents section on additional downloadable models for structures and download any one of over a dozen I have created in HO. Just punch the appropriate sized hole in the wall and insert them just like a window. Fencing was another new addition. Pillars are larger vertical supports and posts are smaller verticals between pillars. Stringers and rails are horizontals. Each of these can be sized and positioned individually. I made this generator over several days, passing time at a library while my house was without power for 4 days due to a storm. Thank heavens for laptop computers and USB drives. River rock is an oddball. I wanted a way to create stone walls for fencing, fireplaces, and the like. I randomly place stretched spheres of various sizes and at random locations. Some painting or weathering would help, but painting and weathering are not my strong points due to poor color vision and general disinterest. I hope to expand on this concept with random cubes representing fieldstones and see if it leads anywhere. I did make an enhancement to my flat roofing generator that I like a lot. I added a ridge line width input parameter that turns a gable roof into a hip roof. This parameter gives total control on how extensive the hip is constructed. even turning the entire roof into a pyramid. The generator makes two pieces, the side panel with triangular notches at the ends and triangular ends, and I then piece them together in Tinkercad. It's a bit complex, but I have a tip video on my website that explains it all. Now let's check out a generator called Construction Tools, and this one needs a bit more explanation. I sometimes found myself needing a triangular shape of a specific odd angle, either as a solid or as a hole. It is a real pain in Tinkercad to create a triangular prism to a specific angle without going through the sines and cosines of trigonometry, and I needed an easier way. So I created a construction tool generator for a solid wedge to any angle I desire. Problem solved. Other shapes like tubes and rectangles are provided for your creative use. Being able to create a rectangle to a specific length is particularly useful in creating setup blocks to a desired length for a chopping tool, like when I want to replicate cuts for the trestle bracing. I just measure for the lengths I want, create rectangular spacers, and bingo! I can set up my chopper and cut as many pieces of strip wood to the proper length anytime I want. The ceiling support is just a set of rectangles the size of a building interior to support a ceiling. I wanted such a thing to support a second floor in a barn, so I made a general solution. Just push it into place, glue it into the walls, and add a piece of styrene to create a support for a second floor. You can also repurpose a ceiling support as a hole to create a lip in a foundation to make adding walls easier and more secure. There will probably be new construction tools as needs arise. Let me know if you think of others that might be useful. Not everything I want for structures justifies a generator. Details like doors, benches, picnic tables, ice machines, roof vents, light fixtures, trash cans, and such are just too varied to justify the effort to create a generator, yet I still wanted them. So I created a section on my website, http://daACKM.github.io, which contains stereolithography files for a bunch of details I designed, usually in Tinkercad. For doors, just punch a hole in a wall like I demonstrated for windows. While you can size these in your slicer, I do not give you control of individual dimensions like you have in a generator. But they are useful when you need a part quickly and don't want to drive to the hobby store or wait for mail order. All of my generators run under Microsoft Windows and can be downloaded from my website at http://daACKM.github.io. When opening the website, you will see a brief introduction followed by a table of contents. The first major entry is for automating CAD. There are links to various videos, a handout, followed by the list of generators currently available, and some I hope to create in the future. Just above the table is an explanation of how to download the generators, so just click where it says, "Click here." A download screen appears, and you click on the download button at the right, the one that looks like a down arrow pointing into a rectangular channel. A zip file will be transferred to your download folder. Depending on your browser, you may get a pop-up saying the file is not commonly downloaded and may be dangerous. Well, that's true. This file is not commonly downloaded. But if you want my programs, you are going to have to trust me. So click on the arrow and then Keep to keep the zip file. Once the file is downloaded, open your Downloads folder and double-click on the automatingcad.zip file. you will see a list of generator executable files. I suggest that you create a new folder and extract them all to this new folder. Then use your virus scanning software and scan the new folder. Or you could just double-click on one of the executables to launch it straight away. The first time you attempt to launch a generator, Windows Defender may try to block the program because it does not recognize me as a commercial software publisher. No matter. Just click on the More Info area and then on Run Anyway, and the generator will launch. You only need to do this once for each generator program. Just for grins, here are some structures I created for entry in my division's November 2024 annual meet and celebration, each of which used one or more components created by a generator. The walls of STEM's florist were created using the generator for brick walls. The front wall is standard bricks, the back and one side wall are construction blocks, and the side wall with the windows is a composite of bricks and blocks. The roof was made with the arched roofing generator. I made the window frames, doors, and roof details in CAD. I printed the walls individually and flat on the build plate, then glued together. The roof was printed standing on its edge. All were printed at a standard layer height of 0.20 millimeters. Here we have an abandoned church's chicken restaurant about 5 miles from my home. I used the basic building generator with the board and batten option for the wainscoting and the lean-to. Both of these components were applied to the outside of a hollow rectangle and composited in CAD. The roof is a separate piece, started as a solid rectangle, with board and batten pieces added as slanted objects to disguise the roof details, which I created manually in CAD. Still to be added are roof details and some ladders. This is the Tidewater house, modeled after the former home of Friends. It features multiple intersecting roof panels, a working garage door, and multiple custom-designed windows, including 2 bay windows. Inside is a staircase and hardwood flooring. All of these were created using my generator technology. I even created the dormers as small basic buildings with clapboard siding and tab shingles, then inserted into the main roof, thus combining multiple simple objects into a more complex one. The dormers were intimidating at first, but fairly simple once I got over my fears. Still to be added are second floor walls and some plumbing fixtures I downloaded from Thingiverse. Finally, here is a greenhouse, a rough approximation of one of several such structures in a nursery in the next county. The base is made with the bricks generator, sized for construction blocks, and the canopy was done with the arched roofing generator, using the vertical wall option and printed on its edge. I used a construction tool generator to make a lip on the top surface of the construction blocks into which the canopy would seat. The end pieces were created using the basic building's board and batten option. I then used the arch roofing generator's roof mask option to create the end walls so they made it perfectly with the arched roof. The heater was created with the louver generator. The movable doors are created in CAD, and the irrigation pipes and planter boxes were drawn manually in CAD. Admittedly, it took a few iterations to get it right. So what might be coming in the future? In addition to staircase upgrades, awning options, and other general improvements, I would like to create windows in shapes other than rectangles, possibly round tops or peaked for churches, and a bay window option too. Perhaps custom-sized storefronts for commercial buildings, gutters too. I want to add simple plate girder and truss bridges to this set. I'd also like to learn how to do texture mapping for stonework as well. When I first developed the concept back in 2022, it was my intent to create a video for each generator, wherein each option would be explained and demonstrated. That never happened, and the only documentation for them is this clinic. Users are left to their own trial and error to learn what can be done, and the lack of better documentation is an embarrassment to me. Documentation is underway, but it takes more time than writing the software. Wish me luck. To conclude, if you have a 3D printer and want to create some custom buildings, you now have some new tools to do so, all without learning CAD. If you don't yet have a 3D printer and have even the slightest interest in the technology, I encourage you to take the plunge. And when you do, give my generators a try. I think you will be glad you did. Thanks for listening.